All right, cool. So let's get started. We got everybody here. I've got just some instructor notes. This is mostly just a cheat sheet for myself. This isn't really like slides or anything, but this is a good thing for everybody to look at. Just a quick lecture on just history of Java, since I know that some people have actually seen Java before, like 12 years ago or 15 years ago, or something like that. Java's actually pretty old now. Started out as a project within Sun. Sun had always been doing a lot of systems development, and they were tackling some new projects, and basically they had done all their work previously in C, right? Because C is the systems programming language that everybody knows. If you're gonna build any sort of operating systems or anything like that, any networking software, whatever, you would do it in C. They weren't happy with that because C has lots of obvious shortcomings, which I'm sure we'll end up talking about throughout this class. I always like to compare Java to C. So they wanted a new platform on which to build these systems that they were building. And so they set out in the early 90s to build this thing that they called Oak, which was named because it was like Bill Joy or something like that. One of the guys just had an oak tree outside of his window, so he just called it Oak. Not very interesting. And it was a combination of two things. It was intended to be a new programming language as well as a runtime system on which the language would run. So essentially like an interpreter and a set of libraries, right? They wanted to use this for embedded devices. Their initial project, actually, I know that you guys are working on set-top boxes now. This is something that they were trying to do in the early 90s. Long story short, in 1995, they decided that they had failed their business ventures with the it was like one of the cable companies. I don't remember who it was, but their set-top box totally failed. Their idea of doing a PDA totally failed. Everything failed. But the thing that they saw on the horizon that they might possibly be able to capitalize on was this new World Wide Web thing that was very exciting at the time. Right, this was 1995, and somebody said, one of the guys who was working on this Oak project, which they renamed it at some point to Java. One of the guys who was working on this said, "Oh, I know, the web is really cool. I'll make a web browser in Java." So he did. I remember using this. This was like 1995. And it was the hot Java web browser, which was kind of cool because Netscape, I don't know if you remember like Netscape 2.x or whatever, you actually had to pay for that. You actually had to pay for Netscape unless you got an academic license. So the hot Java web browser was kind of cool in that regard, and it also introduced this idea of applets, the idea of extending HTML with some code that you could run inside the web browser. So that was kind of neat. And that was essentially where Java started to get a little bit of a foothold, because the web was really just that hot. From there, they said, okay, well, we've got the client side covered. They have a web browser. They have this applets thing. But what, say 1996, 97 or so, what were people writing web servers in? What were people writing the server side of websites in, especially like large websites? Anybody remember? If you were gonna write a big website in 1997, what would you have used? Well, HTML, sure. And what would you have used for all of the logic of the site?
ASP.
Oh, ASP, yeah, it's a good, yeah, Perl, like Apache with mod Perl, right? ASP.NET, yeah, stuff like that. Actually, ASP was a little bit later, I think.
Yeah.
It was maybe 2000 or something.
98, 99.
Yeah. yeah, mod Perl was big. Just CGI scripts, and you can write CGI scripts in whatever language you wanted to. People were doing this in C even, which was horrifying. So anyway, the guys at Sun sort of looked at that and said, "Oh, I know, we can do better. We can let people write websites in Java." And that's where this whole servlets, all this stuff listed here. That's where all that came from. They said, oh, we can take over in that space, which was a great idea. That was pretty successful at the time, but there was a big problem, which is that it was slow. It was terribly, terribly slow. And this is what names. Was it Tanu? Yes. Yeah. This is what Tanu was talking about. The idea that Java was totally unacceptable for any real-time applications. Java was dog slow. It was somewhere between 20 to 100 times slower than the equivalent application written in C. Right. This was an issue. So it had performance maybe comparable with Perl, maybe, but I mean even Perl was pretty fast at the time. So they did a fair amount of groundwork rewriting the Java virtual machine. We'll talk about what that is in a bit, to improve performance. And the key enabler of that was something called just-in-time compilation, or JIT compilation. JIT, right? JIT compilation. The idea was that you take your Java code, and it's running in this essentially an interpreter. The interpreter can, on the fly, compile that down to machine code, just as if it had been written in C, for example. It compiles it on the fly down to machine, like assembler. Right? So this was included in Java 1.3 and was a really big deal. I mean, it basically enabled people to sort of make that technology choice. So that was, I think, a big deal for Java. Then basically nothing happened for a while. People used Java. They're between thank you. Between 99 and 2004, there was Java 1.4, and there were point releases of that. So they introduced new libraries and so on. But nothing really like earth-shattering happened. Until 2004, which is when Java 5 came out. In Java 5, the language actually changed quite a bit. Right? A lot of you guys who used Java prior to Java 1.5 will never have seen something like generics or for each loops or enums or things like that. There were a lot of new annotations, new things introduced into the language that really. So the hotspot made the JVM viable. The Java 5 language changes made the Java language viable. So two halves to the same picture, and that's I think where and the concurrency stuff as well. So that's where it started becoming a little bit more pleasant to program in the Java language, because it was really, to be honest, a pretty crappy language up until that point. It's still not the best language in the world. And I'm not here to sell you on the merits of Java. I don't work for Oracle, so that's good. Not the best language in the world, but it's a lot better than it was. You can write pretty expressive code in it. You can do a pretty good job. And then up through now, again there were relatively minimal changes in the language. The big additions, for example, in Java 7. Were new additions to the concurrency package. It was like the fork join framework and stuff like that. So that's useful for distributed application development. Anyway, that's sort of the brief history lesson. Java is obviously very popular now. There's millions and millions of installations of Java. Lots of people are writing code in Java for all different kinds of things, and finally we come back to 1990 when they were trying to use this as an embedded solution, and hey, we've got Android, right? All right, so you got Android phones. Well, those are all running Java. So Java is actually fairly ubiquitous now, and the JVM is also fairly ubiquitous, even more so because there are also other languages now that run on the JVM. Right? It's not just Java that compiles to the JVM. There's also like Groovy and Scala and Clojure and a bunch of others. Yeah, you had a question?
So I think I heard you say that Java is not the popular language, but so why are we still learning? Why are we still developing in Java then?
No, it's an immensely popular language. I said it's not the best language.
So why not go to the best? I mean, why are we still stuck with Java?
And what is the best?
That's an excellent question. How to answer that though?
Because it's free.
Well, they're all pretty much free. For example, I teach classes on Scala. Scala is also free. It's open source, but it's also new, and some people regard it as basically unproven.
Is this not the best for web? I mean, it's not the best maybe in general, but isn't there some sector where it can be the best?
It's definitely got a lot of, well, so this is here. I won't directly answer the question, but maybe this will help. The big appeal of the Java platform is the fact that there's this huge ecosystem behind it. Right? So we're going to be using the Eclipse IDE. Eclipse is very mature. It's a great development environment. We might get a chance to do some stuff with Maven, again, depending on whether that's interesting to you guys. And Maven provides access to tens of thousands of open source libraries that are out there. Right? This isn't so much the case when you're working, for example, in C. Like the set of, even though C has been around forever, even so, the set of tools, development tools, debugging tools, open source libraries, and so on for C and C++ is actually less than there is in the Java world. And I'm honestly not sure why that is. And, I think partly is because Java started getting really popular at the same time that there was this big open source movement in the 90s. So people just sort of adopted both models at the same time, maybe. I don't know. But definitely, the appeal of using Java is, or at least the JVM, is that you get to use these, all of these tools that are out there, as well as open source libraries like Spring or Hibernate or who knows, all these different things. Web servers like Tomcat and JBoss and so on, right?
I think it's because of the platform independence nature of Java and the virtual machine that triggered Java to spread more. Because if you write in C++, you take care of different architectures at that point of time.
I think that was definitely a contributing factor. Yeah. And we'll talk about that in just a little bit as well.
Isn't it also what you're teaching in school and have been for a while? So people generally do what they know, right?
Yes, people do. So that's probably a more accurate answer to your question. Is people are comfortable with Java. That's why we're using Java. It's because people know it.
So the reason I asked that question is because are we learning something which is probably not relevant 10 years down the line? It's not the best, right?
No. Java, I wouldn't be teaching these classes if I thought that Java was dead. I think Java will never die. I think that there are other. So, for example, Scala. I personally like Scala. I like it better than Java. But it's also sort of a heavyweight language in some respects. Java is sort of lighter weight.
For example, for web, right, we have all these new frameworks, Ruby, Rails, and all that stuff, right?
Sure.
So I don't see people still developing web applications in Rails.
Yeah, Rails.
Java, so.
Rails. Well, don't get me started about Rails. Yeah. All right. Anyway, we'll maybe address that topic a few times throughout the course. There are going to be some things that we'll learn in this class that I'm going to tell you, like, this is really cool. This is something Java has that other languages don't have. And there are going to be some things that we'll do where I'm going to be like, this is sort of a wart. This is something that you have to do just because it's Java, and because Java isn't the best thing out there. Whatever. So there's a bit of both, and there's always compromises, right? I don't think any of you can stand up and say like, yeah, Perl is the best language ever, right? Or Tickle is like the best platform ever for what, right? So there's always compromises. I think Java made its set of compromises and so on. All right, what I want to do, and this is just to sort of make sure that everybody's set up, and to kind of whet everybody's appetite a little bit, is Hello World. This is what my instructor notes are telling me to do. So first of all, is there anybody who didn't get the setup instructions for this class?
I just got it.
Just got a couple. Okay. Do you guys at least have the JDK installed?
No, but I have Eclipse everything installed for the project already, so I can use it.
Oh, you have Eclipse. Okay.
Yeah.
All right.
Remote machine, that machine that I can access.
Okay.
Instruction does not tell what flavor of Eclipse would be the best one, so I installed Juno.
There was a link in the setup instructions to the correct version.
I guess, at least in my case, it was linked to whatever it is.
All right.
But it didn't.
Doesn't matter. Everybody else have the JDK installed? Yeah. You can run Java-C from the command line and everything is happy? Yeah. That's... I don't know. Maybe. Probably. We're going to be doing this class in Java 7. I used to teach this in Java 6, but Java 7 is generally available now, even for the Mac, which it wasn't. Yeah?
Yeah, which version you recommend for Mac? Is it, because for Mac they have different versioning system of Java. So, yeah,
No.
when I try to execute it, it says Java 1.037.
Hmm?
Yeah.
Java 1.6.
You'll be okay with Java 1.6 for now. For you guys,
1.60, some 31.
all right. For you guys who don't have Java 7 yet on the Mac, just Google for JDK. You Google for JDK, you'll get the Java SE downloads page. Yeah, that'll be the first hit. And there'll be a download link for the JDK here.
I think this is 10.7 version.
There was some issue with that. I'm assuming you should pretty much all be able to do this. Doesn't matter. You'll have time to take care of it. For now, if you guys just have Java 6, that's fine. No big deal. There'll just be some small things through the course that'll be different. Okay. So what I want to do is just open up, not even Eclipse, just open up a text editor. So I'm just going to do this right here in my text editor window, and I want to do kind of a group exercise where we try to imagine what Hello World might look like. And if you already know what Hello World looks like in Java, don't say anything. I want the people who haven't seen Java before to try to derive this. We're gonna be doing something that I like to call compiler error driven development. You've heard of test driven development, right? Behavior driven development. This is error driven development. We're gonna try writing some code and see if the compiler accepts it, and we'll hopefully come around to a solution that way. Okay. So we have some sort of text editor open, Notepad or whatever. Yeah. All right. So let's say you were going to write Hello World in, I don't know, Tickle. What would that look like? Puts. Okay. Do I need parentheses or anything?
Quotes.
Quotes. Okay. Hello World. All right. There we go. Puts Hello World. Cool. Let's save this.
And the path to the interpreter.
Oh yeah. All right. Here, let me gotta find a place to put this. I'll just put it on the desktop, I guess. Save as hello.java. right, here we go. All right, I'll go to my terminal. All right. Actually, you know what? Let's put this in. There we go. All right. So I don't know if everybody can everybody see this? Okay, is the projector working well for you guys? Yeah. All right. If you're in the back and you have eye problems, you should probably move forwards. All right. Okay, so we've got puts hello world, and we need to run this program, right? We have a script and we need to run it. Okay. How do we do that?
You have to save it with correct extension.
We've done that. We've got hello.java.
And
They have a class.
we have to go to command prompt, right?
Yep. So we're here.
Java C.
Oh, okay. So you already know about the compiler, right? Because we can't. So I've got my Java program here, right? I can't just say Java hello.java, right? It's not happy with that. It needs to look for some sort of a class. What was your name again?
Arabic.
Arabic. I'm going to mispronounce that for 5 days. I apologize. She mentioned that you need to have a .class file. You need to compile this thing, right? Okay. Everybody knows what a compiler is? Yeah. All right.
It makes just whatever is written readable by computer. Kind of translates.
Yes, it's translating, right? So, for example, if you run a C compiler, it's taking C source code, and what's it translating it to? Machine language. Yeah, machine language, right? Okay, so if I run a Java compiler, it's going to take Java and translate it to some sort of language that can be executed as well, right? So the Java compiler is something called Java C. Seems like a few people have seen that before. So you would say Java C hello.java, and that should, if we have good Java code, that should compile this into something that we can then run, right? So we say Java C hello.java, and all right, we've got an error on line 1. Class interface or enum expected. Yeah. Class interface or enum expected. What do you think that's telling us? Right, yeah, Java's an object-oriented language. We don't have a class defined. All right, so what's a class?
It's a constructor or something programming.
Well, let's write one and just see what this looks like. Class. Let's say class hello. All right, here we go. Class hello. So I'll save that, and just to prove a point here. Okay. So the compiler is no longer complaining that it needs a class because we have one now. All right. So before we go any further, what is this thing? So why have I just put this code inside of a block like this? What does that do?
Is that like a procedure?
No. We'll get to that. We're going to need something like that next.
It has to be like variable names and inside
Yeah, a class is a place to put stuff. Yeah, right. A class is, we can think, this will just be sort of hand wavy terminology for now. because we're not really going to get into object-oriented programming yet. Not for another day or so. We can say that a class is just a logical unit or a module, right? It's a place to put stuff. It's like a namespace, perhaps, right? So it's a logical grouping of stuff, right? So it's where we're going to put all of our procedures. It's where we're going to put all of our data. Yeah, can put them into classes, and you would you wouldn't have your whole program in one class. You'd probably have lots of different classes that represent some logical groupings. Right? Okay, Java requires that everything lives inside a class. Right? You can't just have code that's floating around somewhere not inside a class, right? So when I say inside a class, I mean inside this lexical scope and inside the curly braces. Yeah. Obvious enough?
I still have an error.
Yes. So do I. Yeah. Right. This is now Java tickle. Right. This is jickle or something. Printf. Okay, we can try printf. So that'd be a little bit more like C, right? Printf, hello world. And so if this were C, you would need a semicolon, right, at the end. So printf, hello world, right? All right, let's try this. It thinks. So what does this tell you? What's invalid method declaration? Yeah, it's not a method. All right, what's a method? A function, a procedure. Yeah, Java, of course, is different. Not because it's actually different, but it just likes to have different names for things, right? So we don't call them functions, we don't call them procedures, we call them methods. And I'm going to screw that up, so anytime I call it a function, yell at me, all right? But that's all it is. It's just a function. Yeah. So it thinks that we're trying to declare a method called printf.
Which does not belong to Java, right?
Well, I mean, it's just like the place where this appears. Ooh, that was cool. That was neat. Yeah, the place where this printf statement appears inside the class file is actually the place where method declaration should go. That's why it thinks we're trying to declare a method. All right. Well, all right. So hang on a second. Let's say that this was C. Let's say that we were writing a program in C, and we wanted to be able to run the program. What would you need? Yeah, you would need a main of some sort. Yeah. Yeah. All right. Well, let's do something. I'm going to take out this printf statement for a second and just say class hello, just like that. We'll try to minimize this, right? We're minimizing our failures. Yeah. All right. So I'll just save this. We've got a class that has nothing in it. Yeah. All right. Try to compile that, and it succeeds. Great success, right? Okay. So now, and we can see the other thing that happens here is we've got our hello.java. Now we also have hello.class. Hello.class is what the compiler produced. Yeah. All right. So what I want to be able to do is run this now. So I'll say Java hello. Right. We want to run our class. So we'll say Java hello. And it's going to complain to us that there's no main method. Yeah. So that's like what you guys were saying. This is pretty good. The compiler so far has been pretty decent, and the runtime now also has been pretty decent about giving us useful error messages. That's something I want to get you guys used to pretty quickly. Eclipse, as you guys are working in Eclipse, you'll be seeing lots of error messages from the compiler, and I want you to get used to not being too afraid of those, because they're usually more or less understandable. Usually.
Which version are you running? Because I see different error messages.
I'm running Java 7. Anyway, so it's giving us this nice helpful suggestion. It says, please define a main method like this. Okay, so I'll just copy that. Just copy that, and I'll put it into my class hello. Yeah, public static void main with a string something something args. And because this is a method, it needs an open curly brace and a closed curly brace. Yeah. All right, so now we have a class, and the class contains this method, right, this procedure, or this function. So again, I can save this, right? Save this, go back to the terminal, try to compile it, hello.javac, hello.java, and that also compiles, so that's good. And I should be able to run it now if I just say java hello.
Don't you have to close those parentheses?
Um,
I mean, the brackets.
they're closed.
Oh,
Yeah, yeah, that's important, having them balanced like that. So I'll say Java hello, and this is actually a success of sort of, right? We have a main routine or a main procedure, a main method that doesn't do anything, but we wanted it to do hello world, right? So we should put our printf hello world.
Indentation does not make any difference, it's just for easily reading.
Correct. Yeah. Yeah. Indentation isn't important. When we start working though, when we start actually doing our work in Eclipse and so on, I'll be going around the room and checking out everybody's code, giving people help and stuff. And I'm going to really encourage you to make sure that you've got your indentation right, because anytime you have like something like this, it makes it hard to see that there's a bug, right? What's the bug?
Close braces.
Close braces. Yeah. This close brace matches which? This one, I guess. And then this one is unpaired, right? So I need, yeah. Yeah. Okay, so let's try our printf again. Say javac, and oh, all right. So this is a more useful error message now that we have a main method. It says cannot find symbol printf. It knows we're trying to call a method called printf, right? That's what it says. We're trying to call printf, and we're trying to pass it a string, right? This guy here is a string, and it doesn't know what it is. All right. So okay, this is the part where I ask anybody who's done this before in Java to just tell me the answer, because missing a line. Oh, so like pound include standard io.h or something like that, right? That would be C, right? Yeah. Yeah. Oh, it doesn't like that at all. Good thought though. We'll see something like that.
Something meaningful.
Printf. All right. Here's the answer. I'll give you the answer for this one.
Print ln, right? Print
Somebody said, yeah. System.out.println. Yeah. System.out.println. Yeah. Huh. All right.
That's pretty long.
Pretty long. Yeah.
We can define it to just a little part.
Yeah. You can shorten it slightly, but not much. Java is fairly verbose, right? So let's save this and I've got my word here. So let's compile this and let's run it. And okay, so it's working now, right? So that's good. No? Why not? You shouldn't need to import anything. This code should work. So let's make sure that everybody gets it working. What error are you guys getting?
It's class string.
What else? What more does it say?
Location, class, hello, public, stat, void.
It did compile. Just for me, this will display anything because I just compiled, right?
Uh-huh.
In order to see hello world,
You have to actually run it. Yeah. You have to run Java hello. By the way, some people might have done say something like Java hello.class. Right? If you say Java hello.class because this was the thing that we compiled, this won't work. It says I can't load a class called hello.class. Because that would be in a file called hello.class.class. Right.
So extension always has to be done Java, right?
Yeah, for the source, for your Java source, it always has to be .java. For the output, it'll always be .class. And then when you run it, it's always just Java hello. It's always just the name of the class, not the name of the file. Right.
I didn't get that hello.class. I don't think I did.
You ran Java C and it worked though?
Mm-hmm.
All right, I'm going to pause the recording. I'm actually, anybody who doesn't have it working, raise your hands. I will go around the room real quick and make sure we get something going.
Java is not recognizing the runtime. I have to add it to the path. I can run Java, but I cannot.
You might not have the JDK installed. Yeah,
Just
you'll
the
need that.
JRE.
Just JRE, yeah.
I have the JDK installed, but I cannot run the Java C version. Do I have to fix the path?
You probably have to fix the path. Yeah.
No, I get that it's not.
Yeah, and honestly, don't worry about it. Like, don't spend too much time on it because what we're going to do next is move all of this into Eclipse.
Okay.
Eclipse will be able to just do this almost magically. So,
Sure.
so if you don't want to spend time, I recommend it at some point, but don't worry too much now. All right. So let me pause this. I'll go. Cool. Okay. So we've got our class hello. It's got a method, and that method has a statement inside of it. So let's kind of break this down a little bit. Let's see. One thing that might be important that maybe some of you guys paid attention to, maybe not, is that I've got this class called hello with a capital H, right? And it's defined in a file called hello.java with a capital H.
So they have to match.
The names have to match. Yeah, the names have to match.
It could be lowercase, but in both cases, right?
It could be, but it should be uppercase. Just by convention.
This last name should.
Yeah, by convention, class names should be uppercase. Okay. So that's one thing. Let's see.
Could you say, so the program, the snippet that you wrote, right? So what does that public static do actually?
Good question. We will talk about some of these things later. So public is something called an access modifier, and static is something that I really don't want to talk about. Not yet. It's important, but we're not going to get to it until probably like Wednesday.
What is the opposite of static?
Nothing.
Oh, nothing.
Yeah. So we've got some interesting things that we can kind of point out here, right? We've got some reserved words or some keywords, right? What are the keywords in this program?
Void main system class string.
Some of those were correct.
Okay.
All right. So so class, right? Class is a reserved word. Right.
Public and static.
What do I mean? What do I mean by a reserved word or a keyword?
Cannot use it for anything else.
Yeah. Well, specifically, like if I wanted to declare a variable, I couldn't name it class. If I wanted to, I couldn't call it public, right? So these are things that you can't use for the names of things, right? Public, static, void. What else?
Main.
No, main is actually not reserved.
String.
String isn't reserved either.
What about system?
Nope. Nope.
I thought
Yeah. So these are actually
Not
the.
reserved, but they exist already. That's why you cannot use it. Or
No, we could. We could actually make a variable called string. We could make another function called main.
So if we do
Something called
use
system.
use a reserved name
Mhm.
with a thrown arrow.
If you
If we call a class something like class public,
if you say class public, yeah, something like that, or it's like class void. We're going to define a class called void. We'll see what it complains about. It might actually just complain that void is defined in the wrong file name, but I think it won't. It's java c hello.java. There we go. It expects an identifier. All right, so that's a good point then. What's an identifier?
Unique name to that entity.
Yeah, it's a name for something, and it's what you use to identify a thing, right? It's an identifier. So, what are the identifiers here? We know that hello is an identifier. What else?
Anything which is not reserved.
Almost, yeah. Main is an identifier, right? It's the name of a method. And main is kind of special, right? We needed a method called main, but the name is actually just an identifier. String is an identifier. It's the name of a class. Args is an identifier. All of these things are identifiers as well. System, out, and print line, those are all identifiers.
It's like characteristics.
No, they're just names. Like system is the name of a class. Out is the name of a field of that class.
So like I am identified as Yelena, right?
Sure, yeah. So the name of a variable, the name of a class, the name of a method, whatever, right?
Then you mentioned that class name should always match a file name.
Correct.
Does it mean that one file cannot have more than one class?
Yes, very good. Yeah. So one outcome of the fact that your class name has to match your file name is that you can't have another class in here, right? I can't have class foo also defined in here because foo needs to be in foo.java. Yeah.
So it will be like a collection of small files.
Yeah. Well, unfortunately, they do get pretty big anyway. But but yes. Yeah. You break things down, and Java is very rigorous about this. You break things down into a number of different files. And if you want to group them together, let me make sure that I'm still recording here. If you want to group them together, you just put them in the same directory or something like that. And we'll talk about packaging later on as well. Okay.
So it's not like modularized, unlike like Perl, for example, when you have a lot of modules or like portions.
It definitely is. We'll see what that looks like.
so when you call a class from a given directory,
Mhm.
it always is class from the same directory. What if the same class name exists in another directory?
That's also a good question related to packaging. We'll cover packaging later. Yeah, it is possible to do that. For example, I can define a class called string, even though there already exists a class called string. So we'll talk about how that works later, but for now, let's just assume that these names are unique. Okay. Okay. Good enough. Let's talk about main a little bit more because main is kind of special, right? Why did we need? I mean, remember what this looked like in Tickle? Here, let's do Tickle again, right? Puts hello world, right? Right. All right. This is one line of code here for Tickle. This is what depends on how you count it, but maybe 5 lines of code for Java. So why the extra expense? What do we get out of this? Well, maybe we get some structure, I guess. But what's the fundamental difference between a language like Tickle or Perl or Python, right? What's the fundamental difference between a language that's a scripting language?
You have to compile them.
Yeah, you don't compile them, you interpret them, and where does the interpreter start the program? Like where does it start interpreting?
The second first line.
The first line of the file. Yeah, exactly, right? I just write a line of code and there it is. It's the first thing that happens. And how do you define a procedure in Tickle? What does that look like? Proc, and then foo or something, and stuff. I don't know. Whatever. I don't know Tickle. And And so if this appears somewhere in the code, then Tickle knows how to get to it. But fundamentally, you don't have to put things in procedures, right? You can write a program that just runs from top to bottom, and that's a script. Well, Java isn't like that at all, right? Java isn't like that at all. Java is not a scripting language. So when you compile this file, it's not like it starts at the top and says that these instructions are going to be executed in order.
It goes somewhere, right?
It needs some sort of an entry point. When you run Java, Java needs a place to start. So that's like, for you guys who've done C programming before, what's the entry point for a C program? Main. Yeah. Well, same thing here. Right? So main needs to be defined somewhere, right? And if we have, we can have other methods, like let's define another method. I'll just do it the same way: public static void foo. Right? I don't know. Foo. Right? So I can define another method. And when I run this program, what's it going to do?
It's going to say hello world.
It's going to say hello world. What about this one?
You haven't called it yet.
It's not. Yeah, I'm not calling this method. Right? Yeah, I haven't called this procedure.
In main.
Yeah. Yeah, exactly. If I wanted to call it, I could. I could say foo. Right?
So it has to be inside same curly parentheses.
Well, it's yeah. I mean, basically, main is where the program starts, and if we want anything else to happen, we have to call it from main.
So it will not see anything underneath of parentheses.
Well, or outside of, right? I can put foo up here. The order doesn't matter. Yeah. Yeah. What's the entry point now? Still main. Yes. Yeah. So we're compiling a class, and the class has two methods, but the only one that's interesting, the only one that's called, is just main. Right?
Can I have another one with main? If I put main between void and foo, will it work, or only one main could be in the file?
That's a complicated question.
Can you have more than one main method with different variables?
No, main always, well, that's sort of the same question. It's complicated. You can, but it won't do what you want. It won't do what you want. So typically, an application has one main method, right? You can have lots of different classes, right? Lots of different classes, lots of different methods in each class, but there's going to basically just be one main method.
How can I have multiple classes in the same file? I cannot.
Not in the same file,
In general.
but in different files, and you would just compile them all.
Each file should have main.
No. It can, but you don't need to.
So if this one, let's say how it used to be originally, class hello and public static void main, blah blah blah, right?
Mm-hmm.
So this would be my kind of main class hello.
Sure.
If I write class
Foo, whatever.
good afternoon, right?
Yeah.
I don't have to put main anymore in that.
Depends what you want to do.
If I want, for example, to group them, and so it will be running together, like hello world and then good afternoon people.
If
You said
yeah, well,
every
so
class file should have. You mentioned that every Java file has to have main in it.
mm-hmm.
So I'm trying to figure out.
Right. So let's say you were going to define another class called good afternoon.
Which I cannot do in this file.
Right. You would do it in a separate file. We can do that. We can make a new, class good afternoon, and I can define a procedure, right? A method, public static void. I'll just call it foo. I don't know. Doesn't matter. Good afternoon. Right. And I'll save this. Good afternoon.java, right? All right, so now I've got two files. I've got my hello.java and my goodafternoon.java. Hello has a main. Good afternoon just has a foo. Here, let me delete this just to make it very clear. Okay.
So it still has to have void, but doesn't have to have main.
That's not the important part.
Okay.
What's going to happen with these? My hello and my good afternoon. Here, let's save this. Let's save these both and see what happens.
So I cannot probably run good afternoon independently, right?
Correct. Doesn't have a main, right? We haven't written one. So let's compile this. Let's walk through this. Java C. So we need to do Java C hello.java and good afternoon.java. Yeah. So we'll compile them both. And what am I going to run?
You have to package something. Oh, I don't know.
What do you want to do?
Oh, the food.
I think that's a good answer, right? So in hello, you would say something like good afternoon dot foo, right?
So it would know that you have to go to that file, good afternoon, that Java, and read from that file.
Right. So now here let's compile this again, and I'll run. So what am I going to run?
Hello.
Hello. Yes. Java hello. So I run Java hello because that's where the main method is.
And it will read from both files.
And it's using the methods that we've defined in both files.
Mhm.
Yeah.
So it just looks in the path, in the current directory and the path to find out.
The short answer, yes. Yeah, it just looks in the path. And you can give it, so there's something called class path, which is the path to find all the classes, right? You can tell it. You can put extra things on the class path. And typically, when you run real Java applications, you'll package everything together in an archive, a jar, and just put the jar in your class path. That'll just have everything. Yeah.
So in this case, if we have two files. One is the hello.java file, and the other one is the goodafternoon.java file.
Yes.
And we had a third file which is goodafternoon1.java file, which also had the same, which is like a copy of the goodafternoon.java.
Mm-hmm.
So will the compiler get confused which one to call?
Well, if you had a file called goodafternoon1.java,
Yeah, and
what class would be defined in it?
It will be goodafternoon1.
Yeah. So there'll be two different class names.
Yeah, but it has the same method, and you are compiling.
Oh, that's okay. So same method. That doesn't matter.
So what I meant was that which one it will pick up from.
Well,
Like in the hello.java, you called one of the
Specify
methods.
the class name.
Oh, okay.
Yeah, we specify it right here.
Okay.
Yeah.
So in your previous example, when there was no good afternoon,
Mhm.
foo was just a method.
Sure.
How would you call that method in hello?
Oh, just the method here.
Well, it was outside, so it can't be outside class hello. I missed that.
Correct.
It cannot be.
It cannot be. Yeah, everything has to be inside a class. Yeah. How do we call it? Well, we can just say foo. Yeah. Yeah. And if you want to be really explicit, you can say hello.foo. Right?
It's probably going to look within this scope first before going to the
Correct. Yeah.
I was playing around with capital letter and lowercase letter.
Uh-huh.
I had a lowercase hello.java and get a hello.class. I'm trying to change that to capital letter using Eclipse. And it complains that, okay, the title is already there. I know, but I want to change the name.
Yeah.
I changed the class to the capital H.
Mm-hmm.
And when I try to save the file with capital H, it's complained that the same thing exists, even though it's actually a lowercase.
Because the Mac file system is case insensitive.
Oh.
Yeah. Sorry. So I think.
It's because of Mac. It's not
Yeah. I think you're actually going to be okay, even though you're not supposed to be. But I think it'll work okay.
I guess once.
Sure, I changed. Oh no, I didn't. Yeah.
So Mac, I thought Mac is based on Unix, right? So Unix is case sensitive. How the file system can be case insensitive?
The HFS plus file system by default is case insensitive. You can switch it.
Okay.
But it's a different file system than say Linux. Linux uses the ext file system. This is HFS. It's a different legacy file system.
I have an error which I cannot, I don't see where should I have some missing semicolon.
Ah. I'll let you play with that. I do want to take a break. It's a good break time now.
Just last question.
Yeah.
Can I go to hello.java?
Sure.
So in this, there's a method called the main, right?
Yes.
So that main, can we override this method?
Yes, but it won't be very useful.
Okay. I mean, like when you have compiled the code and then you want to run it, right?
Mm-hmm.
And you want to provide some arguments. So let's suppose we have two copies of main.
Mm-hmm.
One is there's another copy, but the arguments of that are different.
Yeah.
This doesn't take any command line arguments.
Sure.
So, and when we are giving a command line argument, when we are doing the Java with a class name, and then some other argument, will it run the function which is in statement 7, or will it run?
This is the only one that it will ever use. Again, because main is sort of special. It expects that main always looks exactly like this.
Okay,
So this will compile. It's not going to complain about this, but it's never going to actually use it. It's never going to actually run the code.
Okay.
Yeah.
So the main should always have a string
String array args.
string
Yeah.
with the args.
Yeah. Yeah. Okay. Let's take a break. What I like to do with my breaks is give you as much time as you want, which is sometimes good, sometimes bad. I like to say 5-minute break, 10-minute break, whatever. But people come back whenever they feel like. So what I'm going to say is come back when you feel sufficiently guilty about not being here.
But what if we have different sense of guilt?
No, this is the interesting thing. This is the very interesting thing. We get to actually judge people's different senses of guilt by when they come back.
I think we got power supply.
Okay.
Building 7.
Huh? When should you first start feeling guilty? Excellent question. So come back whenever you feel guilty, and we'll start up. We'll do this exercise again in Eclipse, and we'll start talking about the different data types that we've seen. Okay.
So where is your